Complex numbers can be represented as coordinate pair. That means we can plot them. Usually the horizontal axis represents the real part and the vertical axis represents the imaginary part. So if we were given complex number 1, 2, it would map to 1 for the real part and 2 for the imaginary part. We can think of it as a vector. To find the modulus of a vector, it is given by x squared plus y squared all taken square root of. For complex numbers, it so happens that x plus iy, which is our original number, times x minus iy gives precisely the above relation. So the first number is our z, and we call the other number complex conjugate. So complex conjugate of z is given by x minus y. It is really useful to consider the properties of complex conjugates. To get the complex conjugate of z, all we do is reverse the sign in front of the imaginary part. It works that if you have a sum of z1 and z2 and you take their complex conjugate, it'll just be the sum of complex conjugate of z1 and the sum of complex conjugate of z2. Same goes for the multiplication. We can sort of distribute in the complex conjugate. And also, of course, this works for the division. So the complex conjugate of z1 over z2 is just the complex conjugate of z1 divided by z2. Some of the really useful properties of complex conjugates are that the sum of z plus its complex conjugate is equal to times the real part of z. And the difference of z and its complex conjugate is equal to 2i times the imaginary part of z. These relationships are easy to see. If we were to write them out in terms of the imaginary and real parts, we would find that when we add the complex conjugate of z to z, the imaginary parts cancel out and we're just left with 2 times the real part. And when we subtract the complex conjugate, if we write it out in this case, we will find that this time the real parts cancel out and we are left with 2i times the imaginary part. And given two complex numbers, z1 and z2, the distance between z1 and z2 is given as the modulus of z1 minus z2. Now that we consider distances between 2 points, we can establish the triangular inequality for complex numbers. All that triangular inequality says is that the distance to point, which is given as the sum of z1 and z2, which would be at this point, this distance is less than the sum of the distance to z1 and z2. In a way, this is intuitive because it would not make any sense at all if this point would extend beyond, say, what the distance of this guy is and what the distance of the second guy is.